My name is Jatin Bhatia. This is video for summarize assignment 5. Question number first. Let me share the screen. Here it is 1718080. Question number 1 refers to the yield curve from question number 12 in your assignment 4 to the answer this question. Find the present value of the risk-free 5 years annuity of 1000 per year. Our time period is 5 year, 1 to 5, and cost is $1000, 1000 in every years, and present value is came 947.86. How? With the formula of face value divided by 1 plus interest rate, and this is the total of the present value of the sum of the all years, 5 years. Average yield is 5.77 in second year, and 5 plus 5.82 divided by 2 is the average yield. Average yield is 5.795, and so 1000 divided by 0.057, 1 minus 1 divided by this, and present value of annuity is 4246.96. This is the yield rate. This is the yield rate increasing like that. Compute the coupon payment of 1000 bond with 12% coupon rate, and face value is 1000. Coupon rate is 12%, is 0.12. Quarterly is face value into coupon payment rate divided by number of year. Quarterly in 1 year 4 quarter, so divided by 4, $30. In semi-annual, in 1 year two semi-annuals, semi $60. Why is the zero coupon bonds called pure discount bonds? Explain. Zero coupon bond promise to pay only the face value at the majority date, so investor will only pay the price with lower than the face value. If bond price is lower than the face value, that is made traded at discount, and investor regular bonds receiving income from the coupon payments, which are semi-annually or annually. Investor receive the principal or face value of the investment when the bond mature. Question number 4. What is the yield to maturity of $10,000 zero coupon bonds currently traded at the 9,200 with the majority of? Answer is question number A. Face value is 10,000 and P is price is 9,200. Then for 1 year, this is the formula. P is equal to face value divided by 1 plus yield to maturity. 9,200 is P, our P, and 10,000 is our face value. This is given. 1 plus yield to maturity rate is equal to the yield to maturity rate here, and divided by 91 minus 1 is 0.086 approximately, or $8.69. In 5 years, why yield to maturity rate in the term 5 years, we have to need to only here we for 1 year, so now 5 year we need to put here power 5, so our answer is 1.68%. Assume X is the number of the family members, 4 people in the family, and X, what are the cash flow of the 1000 coupon bonds with X% coupon rate. I have 4 members in my family, then X is 4%, face value is 1000, coupon rate is 4%. Semi-annually, 1 year, 2 year, 3 year, 6 year. Semi-annually, in 3 year we have 6 semi-annual, so 1000 into 0.04 divided by 2 is 20 year, and our last semi-annuals, 6 semi-annuals, we need to pay the face value also with $20. That is total $1,020. Annually we have 3 years, so in last year we need to pay 40 plus 1000. Here we didn't divide it by 2 because we have 1 year and no semi-annuals, so annual coupon payment, that's why we divided by 1. Question number 6. Calculate the price of the bonds of the question number 5. Yield to maturity is 3%. Yield to maturity is 3%. Semi-annual 3% divided by 2, 1.5%. That is our 20. here 20 divided by 0.0 is rate, 1 pi minus 1 divided by 1 plus our interest rate. For semi-annual 6 is equal to the $1,028.48. Annually we need to divide by our yield to maturity is 0.03, so 40 divided by 0.03 into 1 minus 1, that is the formula. So come power 3 because of the 3 years, 1028.28. Question number 7, calculate the price of the bond. In question number 5, yield to maturity increased by 5%. Compare your answer to with those in which question number 6, explain why the prices are different. Yield to maturity is 5%, is semi-annually. 5 divided by 2 is 2.5. Yield to maturity rate. P is equal to 20 divided by 0.025 into 1 point minus 1 divided by 1 plus 0.025. Power is 6 because semi-annual, is equal to $972.45. Annually we don't need to divide by 2 because it's annually. In the place of 0.025 we need to put 0.05. So our answer is 972.76, approximately the same in semi-annually and annually. Price of the bond decreases when yield to maturity rate is increases. Bond can be traded at par, discount, or premium. Comment on the bonds in your answer in question number 6 or 7. In question number 6, yield to maturity is decreased, then bond trade at a premium. Price is more than face value of the bonds when yield to maturity rate is less than coupon payment rate. In question number 7, yield to maturity rate is increases, bond trade at a discount, price is less than face value when yield to maturity is more than coupon payment rate. In question number 7, if we change P is equal to 4%, then bond price at par, P is equal to the face value, it's mean yield to maturity rate is equal to the coupon payment. Assume y is your age if you are 21, example, or y is 20. I'm 22, so I took the y is equal to 22. Answer, the year is 22, which face value is 1000. Yield to maturity is 4%. So 1000 divided by 1 plus 0.04 power 22. Answer is 421.95. What return will you earn if you sell the bond in 7 years? Answer, I buy the bonds at price 421.95, 958. Today sell it in 7 years. This is our price of the bond at the end of 7 years. My annual return is 560.98 divided by 421. This is the price of today, and power is 1 divided by 7. Minus 1 is 0.050 is equal to 5.06 approximately. Use y as from question number 9. Consider y year bond with 8% coupon rate and 1000 face value. What is the price of the yield to maturity at 6% newly issued? Y is equal to 22. Our year term of the bonds. Coupon payment is rate 8% annually, which face value is 1000. Then yield to maturity is 6%, and C coupon payment is 80. 80 divided by 0.06 into 1 minus, this is the formula, 0.6061. 21 is the power because 22 year total. So we take the 21 here and 22. That is, no, sorry, here is 22. Oh, sorry. 22, and our answer is 1218.631. In B question, if the yield to maturity is unchanged, price of the bond right before the first coupon payment is made until 21 and 80 at last year 1080 we need to pay with face value 80 and 80 divided by, so we write here 21 because we write 80 here, That's why we write total 22 years. So we write here 21, and answer is 1315.28. If the yield maturity is unchanged, what will the price of the bond right after the first coupon payment is made? 21 years, 80 divided by 0.06, and 1 minus 1 divided by 1 plus 0.06, power 21, because right, first coupon payment is already made. We receive that much money, except the first year money, because in the question situation, they write after the first coupon payment is made. So our answer is P is equal to 1235.28. Explain the relationship between the interest rate and the bond price. What is the duration of the bonds? Bonds have the inverse relationship to interest rate. When interest rate is rise, bond prices fall, and vice versa. When the new bonds are issued, they typically carry coupon rates at or closer to the prevailing market interest rate, and the bond price have inverse relationship. When one goes up and other goes down, at the first glance, inverse relationship between interest rate and yield seems to somewhat illogically, but upon close examination, it makes good sense. In general, the higher the duration, the more of the bond price will drop as interest rate. As a general rule, 1% change in the interest rates, a bond will change approximately 1% opposite direction for every year of this duration. Question number 12. Uh, Using the following zero coupon yield, comparing the yield to maturity of 2 year zero coupon bonds and 3 year coupon bond with 5% annual coupon, assume the face value is 1000 for both. 1000 is face value, our 5 year, so percent is 5%. uh, this is for 2 year and this is for 3 year. Yield to maturity is 2 year. So 1000 divided by 1 plus our interest rate is 5% annual coupon, and year is power 2. If year is 3, then power 3. So 907, and in this yield to maturity rate is 3 years. So power 3. Then our answer is 864.304. Question number 13. Explain the difference between yield to maturity and expected return of the bonds when they are not risk-free. Yield to maturity rate is measure of what of bond investment will earn over its life, and expressed as a percentage. Yield to maturity, YTM, sheds some light on the annual real rate of the return offered by the bond with specific interest rate compared with the other bond on the market. Since yield to maturity require extensive permutation, online yield calculation was the best way to make quick calculation. The expected return of the bond is the interest rate that the bond issue must offer in order to get investors interested. Expected return is the predominantly set by the market forces determined by the price at which issuers and investor agree. Established company with the long-standing reputations and the local governments may be able to away with the paying slightly lower interest than the market rates. Likewise, unknown companies may find it's unnecessary to pay higher than the market rates to get investors to buy it. Last question number 14. Construct the default credit spread graph using the data of the US Treasury yield and corporate bonds of the yield of the online sources. Link to the information you use. So this corporate bond yield, this is the data that I took from the US Treasury yield. Corporate is 1.53, and fifth year 1.77, and 10th year 2.69, 30 years 3.15. So government bond is 0.18, 0.35, 0.69, and 1.43. Credit default, how I found corporate bond yield minus government bond yield, then credit default is came 1.77 minus 0.35 1 is equal to the 1.42, like same in 10 year, 13 year, 30 year. After that, I make the graph on the basis of this data at Excel sheet. See, the government bond yield is lower than the corporate bond yields. This is the difference between two curves. Go positive, and this also, but the government price is lower than the corporate bond yield price, corporate bond yield price. So that is my assignment fifth. Thank you so much for your attention.